So let's just see how we can add two polynomials using the linked list. So here is the algorithm. So suppose we wanted to add two polynomials, like in example we have the polynomial 2x square plus 3x plus 4, and also we have another polynomial like 3x cube plus 4x square plus 5. Now first of all we have to initialize, so we have to create a dummy head for the result list. So we have to create one result list which will hold the result of the addition, and also we have to use two pointers p1 and p2 to traverse the two polynomials. So here we're gonna use the p1 and p2 pointers to traverse these two polynomials. So now we are done with the initialization. Now we have to traverse and compare these two polynomials. So we're gonna use the while loop. The while loop will continue as long as we have the p1 and p2, both of them are not null. So first of all we're gonna check if the p1's exponent is greater than the p2's exponent. So if the p1's exponent is greater than the p2 exponent, in that case we're gonna append p1 to the result and we're gonna move the p1 to the next node. Otherwise, else the p2's exponent is greater than the p1's exponent, in that case we're gonna append the p2 to the result and we're gonna move the p2 to the next node. Otherwise, if they are equal, if their exponents are equal, in that case we can sum their coefficients and append the new node at the end of this result, and then we can move both the p1 and p2 to the next node. And when the loop ends, then we can append the remaining terms to our result. So here we can apply this algorithm. So first of all we have to compare the exponents of the p1 and p2. So here you can see p2's exponent is greater than the p1's. So in that case we're gonna add the p2 to our result, and then we're gonna shift the pointer to the next node. And again we have to compare the exponents of these two nodes from both of the polynomial. You can see both of them are equal, so in that case we have to add them, so it will be 6x square. So we have to append the addition to the result, and then we're gonna shift both of them. So the p1 will be shifted here and p2 will be shifted here, and now we're gonna compare their exponents. So p1's exponent is greater than the p2's exponent, so in that case we're gonna append the p1 to the result. So we're gonna add the 3x to the result, and then we're gonna move the p1, so the p1 pointer will be shifted to the next node, and then again we're gonna compare. So here you can see both of their exponents are equal, so we're gonna add their coefficient and we're gonna append the new node to the result. So here the 9 will be added to the result, and both of them will be shifted, and both of them has become null. So the while loop will exit, and then you can see there are no remaining terms in the polynomial. So in that case this will be our final result. So here let's now see how we can write a function to add two polynomials. So the function will return struct node pointer. So we're gonna call the function add polynomial. So the function will take two polynomials p1 and p2. Now first of all we have to create the result list. So we're gonna create the result list which will initially be null, and also we need another temporary pointer which also be null. Now here we're gonna run the loop. So the loop will continue as long as the p1 or the p2 is not null. So inside the loop we need two variables. We need the coefficient and the exponent. Now here we have to define the three conditions. So first condition is if the p2 is null or the p1 not null and the p1's exponent is greater than the p2 exponent. So when the p1's exponent is greater than the p2 exponent, in that case our coefficient will be coming from the p1. So p1's coefficient will be stored in the variable coefficient, and also the exponent will be coming from the p1 exponent, and then we're gonna shift our p1 to the next node. Otherwise, else if the p1 is null or the P2 is not null and the P2 exponent is greater than the P1 exponent. So in that case, so when the P2 is not null and the P2's exponent is greater than the P1's exponent, so in that case the coefficient will be coming from the P2 coefficient and the exponent will be coming from the P2 exponent, and then we're gonna shift the P2 to the next node. And we have the third condition, else when both the P1 and P2 exponents are equal. In that case the coefficient will be the addition of P1 coefficient plus the P2 coefficient, and the exponent will be from any of them. Let's just take it from P1 exponent because both of them will be same. And also we have to shift the P1 to the next node, and also we have to shift the P2 to the next node. So this is our three conditions. Now after we have to check if the coefficient is not equal 0, then only, so we're gonna create the new node. So here we have to pass the coefficient and the exponent. Now if the result is null, that means there are no nodes in the result list. In that case we're gonna add the new node to the result and the temporary pointer will point to that result. Otherwise, if we have previous nodes in the result list, then the temporary node's next pointer will point to this new node to add that new node at the end of the list, and then we're gonna shift the temporary pointer to point to that new node. So the temporary pointer will always point to that last node so that we can add new nodes to the end of the list. So this way our loop will continue, and when the loop ends, then we're gonna return the result list, which will contain the result or addition of both the P1 and P2. So previously we have created this P1. Let's now create another polynomial P2. So the P2 will have the terms. So the first term has the coefficient 3 and exponent 3. So here we're gonna pass 3 and 3. And next we have 4 and 2. So here we're gonna pass 4 and 2. And the last term has the coefficient 5. So here we have to pass 5 and 0. So our both P1 and P2 are ready. Now we can call the function add polynomial, and we can pass the P1 and the P2. Now this will add those two polynomial and it will return the resulting polynomial. So first of all, let's just print the polynomial. So we're gonna print the P1 and then we're gonna print P2, and after that we're gonna print the result of their addition. So here is the P1, then P2, and here is the result. First of all, we have 3x cube, which is coming from the P2, then the 6x square, which is the addition of this 2x square and 4x square, and then we have the 3x, which is coming from P1, and then the addition of 5 and 4, which is 9. So that means we have successfully added two polynomials using the linked list. So this way we can follow this algorithm and we can add two polynomials using the linked list. So hope you understand the concept. See you in the next one. Take care.